Okay, so the minimum one-way program to Mars, this is a work in progress. We don't have any numbers involved, but I'm estimating numbers based on previous work, and would like to get a group of people together, some with engineering skills, some with other skills, editing and graphics and publicity, and flesh this out. So be thinking about how you personally can contribute to this effort. Okay, and there's my email address. Got major help from Catherine, Banyan, and Calvin, who are not here. Just a real quick reminder, why do we want to settle space or Mars? It's basically resources, places to live, places to keep our cultural diversity, challenging environments. When the Europeans came to America, they didn't know it, but they were putting themselves in a challenging environment, and they came up with all kinds of inventions over hundreds of years. And also learning how to manage ecosystems, which we can then apply the lessons back on Earth. And I actually think that the space program might save the Earth's ecosystem. So, why Mars in particular? It's just like real estate. It's food, food, and food. You got water to grow food, you got carbon for food, and you got nitrogen for fertilizer to grow food. So I don't want to bash the moon. It'd be a great place to visit, a great place to make glass and solar cells, but it's a bad place to grow food. I like to say that a lunar settlement will only be practical when they can import their food from the Martian farmers, or maybe the asteroid farmers. In addition, you have carbon for polymers, which is a key part of the plan. Water for industrial processes. If you lose a little bit of air out of the airlock, you can replenish it. You pump the CO2 into the greenhouse, and the plants make oxygen, and they leave the nitrogen and argon. Going to and from Mars will teach us interplanetary travel, life support, etc. Okay, I think so far it's been a review for everybody. I showed this day before yesterday evening. A typical Mars round-trip exploratory program might be 3 successive crews, might be 3 large craft sent to Mars on the order of 25 tons each. You need about 20 heavy lift vehicles, the sort of Ares 5 or Shuttle C class vehicles for this program. If you don't come back, if you know you're not coming back, is there a cursor visible? Yeah, there it is. You see these big red circles. If you're not planning to come back for a while, you can eliminate the return vehicle, the Ascent Vehicle, and the return vehicle. This will save you half the launch cost, might save you half the development cost. You can put that money into manufacturing spare parts, reliability, etc. Any questions on that concept? Clarifications? We came up with the what we call a Hillside Settlement design down here, built by 12 people with automated equipment. When we came up with our mass estimate, we estimated the mass of all the subsystems and added it up, and we came up to 250 tons, the same cost as the 3 round-trip missions. So which has more impact on the future? A growing base starting with 12 people that has manufacturing capability, or 3 round-trip missions in the history books? So this was a volunteer effort. We had a little bit of paid support, but it was all mostly engineers with, in their spare time. And we went to a fair bit of detail. How many people have seen these last 2 slides before? Whoa. Okay. I owe you guys a half-hour presentation on that. Sorry. We think we can simplify and reduce the cost by eliminating some of the materials, and here's one proposal. We didn't go into any details on this, but basically use fiberglass cylinders made with polyester to bind it, all locally produced. And I'll get to this later, but here's an assembly tent where you wind the composite cylinders, and then an airlock where you outfit them, and then you plug it in and you build your modular town. The canopy is for shielding. And again, this warrants about a 15-minute presentation. Okay, but moving right along. I assume you all know the Augustine Second Commission report and the flexible path. Raise your hand if you know those words. Okay, everybody should raise their hand, but okay, we're going to have a longer presentation. Okay, so when Obama came in, he was concerned that the current NASA plan was not tenable, couldn't be done in the current funding, etc. He got Norm Augustine, a respected, remind me, who was he CEO of? Lockmart? Somebody shouted out. Like, what, the Lockheed? Yeah. And so he ran this report, and they evaluated the NASA constellation plan and concluded that you couldn't do it for the amount of money that was budgeted, and you couldn't do it for any amount that would probably reasonably be budgeted, and therefore it was going to fall flat on its face sooner or later. And they recommend scaling it back to the flexible path, which is design the ships first and then figure out where you go later. And you know, that has all kinds of problems. But the general proposal was, if I can find my cursor. Okay, you see the cursor there around L2. Make Orion capsules and go out beyond low Earth orbit to Lagrange points around the moon, places like that. Then go off to asteroids, and then go to Phobos and Deimos, moons of Mars. And this slide was borrowed from Buzz Aldrin, by the way. We are proposing that from Phobos, you control the exploration of the surface of Mars. And you can do this much more quickly, faster decisions, controlling the rovers. And also deploy a surface base and get it ready for people. So this slide is all I'm going to say about deployment. Want to do it on existing vehicles. We don't want people on Mars who are dependent on a vehicle that is only used for them. We don't want to have to say, oh, this massive Ares 5 launcher that we developed, we can't afford to, something went wrong, we can't afford to fix it. It's only needed by these 3 people on Mars. What do we do? So we really want everything on existing vehicles. So these white modules will be sized to fit on an Atlas 4 or a Delta 4. Atlas 5, Delta 4, or similar vehicle. The larger habitats like this would be sized for the Falcon Heavy, which I'm trying to get figures, but I think it can throw 13 tons to Mars. It's not clear how much you can land in that, but I haven't confirmed that figure. By the way, the Mars Science Lab, Curiosity Lab, I think is launched on Ariane 5 next in a few months, and will be only 900 kilograms on the surface, 1 ton. So that's a major constraint. So here's the Atlas 5. Notice, so here's the payload, and here's the upper stage booster that sends it, say, to geosynchronous or onto the moon or Mars. It really decreases your payload. Probably we'd have to launch 2 of those, one with the interplanetary stage and one with the payload. But we really have to keep this within, at least keep resupply missions within existing boosters. Okay, I'm going to get into our proposed sequence of deploying from orbit onto the surface. This is what it's going to look like, and the numbers, we'll be building up with these numbers a few at a time. And there'll be a quiz in 10 minutes for you to label this diagram. So, okay, you're visiting Phobos or Deimos, or you're in orbit. Maybe you've picked up regolith for shielding. You basically establish a space station in Mars orbit. It could also be on Phobos. And from there, you control the robots. And it'd probably be a crew of 2 in orbit around Mars. And multiple crews. So you'd rotate the crews, or you could have a 2-year gap. So you're controlling all these rovers running around the surface, and you do site selection, and preferably drill for water or make sure you've found water. If I had to choose today, I'd choose this site. This is in the Hellas Basin. There's a ridge here, and there's this strange slope. This slope is too shallow for a scree slope. And when they got the radar mapper in orbit, they get a radar reflection from underneath this slope. So we're pretty sure it's ice. If it's not ice, we really want to know what it is. Be even more interesting. And so you know, here's a dry riverbed. Put your settlement somewhere between the ice and the riverbed. Maybe we can go down the riverbed and scoop up nice deposits that are already separated, so, you know, sand and gravel and silt. But right up against some source of water. Let's see. We will drop down 2 modules for testing. They will contain the critical components that need to be tested for life support. And I would like to have this anthropomorphic robot running around in there, testing this prototype habitat the way a human would. And also throw in a little bit of manufacturing. We can't send Patrick to Mars. By the way, Patrick really helped us out in Chicago at this exhibit. This is a 3D printer. It's basically a hot melt glue gun under computer control. And you can literally make this salt shaker out of thin air from Martian air. So you guys want to pass these around, or? Okay. Let's see. Try it the other way. Okay, so here's our 2. The stuff in the bag is the raw material, and we would have to manufacture that from CO2 or synthetic oil on Mars. And some of those are made from a plaster dust process, and some are made from plastics. I think it's PVC, same thing that you make Legos out of. So we're going to build at the base. Here's our prototype test for all the manufacturing equipment, and here's our prototype habitat. Real tiny, it's just for testing the subsystems. The next phase, after you've confirmed that this is a good site, and you've been running around it for a while, drop down a nuclear power unit, water extraction unit seen here. This is a big compressor, and then you freeze out the CO2 and left with nitrogen and oxygen. And enough test equipment to actually make some fuel, water, and preferably polymers. You know, at least polyethylene, preferably a higher plastic. All controlled from orbit and from Earth. So here's that chemical processing unit. Here's the nuclear unit, unshielded or minimal shielding, and then this is an inflatable connection. Be good to. You really want to know if you can grow food if you're going to go there on a settlement mission. So drop down a greenhouse support unit, and one end can have basically a hothouse test unit. So at one end of this unit, there'd be trays with seeds, and you germinate them and see what happens. Now, I don't want to contaminate the planet until people get there. So I propose that this be a well-sealed unit and capable of being sterilized. So if the program is terminated, we sterilize the greenhouse. So any comments on that? Yeah. Yes, it was the available slide. Yeah. Right, yeah. I would like to have a fair bit of automation, a bunch of little rovers running around, little robots running around, but at least 2 anthropomorphic robots, so that you can, like this one here, this guy with the NASA emblem. So this is a robot that has arms shoulder height to us. It has stereo vision at eye level. And the people in orbit can walk around this greenhouse and become familiar with it and test that all the controls can be handled by a normal-sized person under 3/8 gravity, etc. But mostly just get familiar with it. It's also good publicity. But yeah, I should replace that person with a robot. You're not trying to. I don't think we can get to the point where we're harvesting food and cooking it and stockpiling it and making frozen pizzas, but at least prove that things can grow. So there's the greenhouse support and waste processing unit, and there's a sealed greenhouse. And by the way, around here, the rovers start building a berm for extra radiation shielding. Next, drop down a full-size human-rated habitat with life support system and kitchen. Clean, neat, sterile, waiting for people who aren't there yet. And you just have these robots running around it, checking it out. This is what it looks like before people arrive. This is what it looks like after people arrive. By the way, this is from 1986, Case for Mars #2 conference workshop. And they still have a lot of valid ideas. So it's sad how little work has been done. I just mentioned this. Okay, so by now we have a test hab, a full-size hab, a fabrication lab, at least one greenhouse. We've been testing the light support system. The crew in orbit has becoming familiar with it. We send another crew who are the 2 settlers, and that's one of the. There's a whole bunch of trade-offs here. Number of people, but I think you want more than 1, and I think you want the minimum number. So let's say 2. Some people would call them even atom. Let's see. And, there's the fabrication lab. Thanks to Calvin Lamb for this diagram. Here's a CNC machine, some 3D printers brought from Earth. This is a drafting table that was available in his part library, but we'll call it an assembly area. A water jet cutter. Not shown would be a plastic sheet production. Make sheets like acrylic that you can then cut and make furniture. Injection molder. These little 3D printers can make a bigger 3D printer that is not shown, and maybe a robot specialized for assembly. Any comments on manufacturing? Yes? Oh, okay. I've got phase numbers in the top. You could spread it out so that each phase is independent and 2 years apart or even 4 years apart. You could also compress it down to about 3 cycles. So many of these phases could be done simultaneously, depending on available funds and launch vehicles. You could get it down to about 4 phases over 8 years. But we need a gap between the testing and the deployment of the real thing, for correct. Yeah. Okay, raw materials. For plastics, it's mostly carbon dioxide from the air, and assuming we are next to one of these ice flows, we would be drilling in and heating the ice and getting water vapor out for water and hydrogen to make polymers. We might be able to drill down to get permafrost. If need be, you could dehydrate the air, but that's very energy intensive. Let's only do questions of clarification now. Okay, so this last unit over here is the habitat, and throw in an extra greenhouse. Yeah. Okay. It's sized to the launch vehicle. These small modules might be 2.5 to 3 meters across. We wanted these big modules to be 5 meters across, which is kind of like from me to that far wall. It'd probably have to be smaller because the Falcon Heavy, I think, has a slightly smaller fairing. But let me keep going. We've got 10 minutes. Okay, so when you're completely comfortable that the life support system is working, that the repair facilities can be made to work, power, water supply, air, fuel, etc. 2 people who are planning to go to the surface go out to the Mars space station. They teleoperate the base for a while with these anthropomorphic robots. They get familiar with it. When they're all ready, they descend to the surface. We have not yet funded their ascent craft. So their ascent craft is at least 10 years off. Okay, but that's a cost thing, and I personally don't think this program will be funded if we have to fund the ascent craft. So, okay, and chances are there'll be a few things they have to fix by hand. In this diagram, the robots never finished shielding, getting the regolith over. Here they're repairing one of the gas tanks. There's bound to be a lot of stuff for them to fix. Deploy a lot of greenhouses. I happen to like the side-lit greenhouses with mirrors over here to send the light in sideways and cover it with a canopy and radiation shielding. You didn't really need that until the people arrived. Okay, so that's what it'll look like for these 2 people. Oh, by the way, there's actually 4 crew members. 2 of them are in orbit controlling the robots. So it's not 2 people by themselves. They have real-time interaction and help from these teleoperated robots. Okay, so there's the numbered sequence. And each one, I hope, would be one launch. It might be one launch plus fuel. I really don't have time for questions, sorry. I'm going to deliberately run out to 30 minutes, then take questions, and then there'll be another thing talking about a student project. Okay, long after that, I think at this stage, you'll be sending cargo out there, and the cargo container can become a new habitat. But at some point, you won't need as much cargo, and then you want to start manufacturing pressure vessels to live in. And here's our design for an assembly tent inflated. We originally thought it'd be brought from Earth, but maybe you could make it in strips in a tight confinement. So here's this assembly tent with a nice flat floor, pretty wide, cables to pinch the sides in, and here's a module that might be made out of fiberglass and being wound in there. Fiberglass or spun basalt. Basalt fiber made on site with polymers. Here's balconies for robots and people to work on the top side. And this is what it might look like later. By now, you'd have a bunch of people, arrived, and you'd be spending more and more of your time on science. But here's you bring the dirt in here, you manufacture your basalt fiber, you spin it in this assembly tent, you outfit it in this airlock, you bring it out and plug it in. Other construction techniques. I love masonry covered by dirt to hold the air pressure. Stop by one of the tables during a break, and I'll tell you all about it. Someday we'll have an Ascent Vehicle. It might actually have to have some major components made on site by the people there. So, at some point, this settlement is not necessarily a scientific settlement. It's sited where you have the resources for manufacturing. It may not be the best place to do science. Okay, so you might want to start manufacturing Conestoga wagons. You rename your settlement St. Louis. People take the train from the East Coast to St. Louis. They buy their Conestoga wagon, and they go out prospecting for minerals or scientific interest. At some point, people will be born there, or you'll have mail-order grooms and mail-order brides and whatnot. And I'm almost done. Okay. Who's seen the diagram in the upper left? Nobody. These two pictures are related. The upper left is the original plan that morphed into the lower right, Hillside Settlement. Okay, 5 minutes. The proposal that I just presented is about at that stage. And a lot of you guys in the audience might enjoy working out some of the details for one aspect of it, or planning one of the modules. So let's put a team together and go from the upper left to the lower right for minimal cost within the existing, budget and existing launch vehicles. So that's my conclusion. Oops, I'm sorry. I put the labels in there by mistake. You don't have to. You don't get the quiz. Okay. I am 4 minutes ahead of schedule, so sorry about that. I'll take questions, clarifications, discussion for about 10 minutes, and then I will talk about if you saw these sheets, there are 4 WPI students, 4 students at WPI. It's a major engineering university in central Massachusetts, and they'll be working next year probably designing one of these modules and then making educational activities related to it, such as taking the 3D printers into schools and showing the kids how to build, a habitat on Mars or how to build a custom bicycle on Earth. So that's what's going to happen in this room after questions.
Have you considered designing part of your habitat out of the upper stage and then launching it wet?
We didn't consider it for this. A major problem is entry, descent, and landing. So you need an aeroshell. Up until now, they've had an aeroshell inside a fairing, and it's incredibly inefficient. what I would like to do is design a upper stage with an aeroshell as part of it. If there's anybody in the room that wants to be the lead person on that, you do need a fair bit of aerodynamics for that, though. I think that's a great idea, maybe not for Mars, but maybe for space stations. So, because of the entry problem. Question? Yes? Oh, I'm sorry. Yeah, I'm sorry. Yeah, I should clarify that. Oops. No, they would come back to Earth. I'm going to guess it's about slide 6. Let's see. No, a two-person crew. So you see these red lines. Now, by the way, this is not my plan. This is the flexible path approach, and this particular diagram is Buzz Aldrin's version of it. So 2 people come out. Well, first you send an unmanned HAB to Phobos, and you land it here in this dotted line. Then you send 2 people out, and they inhabit it for 500 days or so. And then they return to Earth. Then another crew comes out. And I'm hoping you could minimize those numbers of crews, get it down to about 1 or 2 crews. But once you have people on the surface here, then you really want a crew in orbit until they're secure to help them out in emergencies. So you'd have maybe 2 crews in orbit, one doing the exploration, a second one doing the deployment, and then 4 people come out, 2 of them descend to the surface, and 2 of them stay in orbit. And that group of 4 works as a team, surviving on Mars. And then the people in orbit might return every 2 years. Yes. The vehicle to return from Mars orbit is the same as you go out to Mars. So you don't need to develop a new vehicle. You do need fuel for it, though. Yes, you're right. You're right. When I said you save half the cost, that was actually for the Hillside Settlement design. Yeah. In this case, it's somewhat less than half the cost, but it's something that we're planning to do anyway. So we're just piggybacking on the flexible path program. Well, Zubrin has a lot of different plans. There's Mars Direct and there's Transorbital Railroad. Mars Direct is quite different. Mars Direct is exploration, bringing hydrogen from Earth. With the inflatable HABs, yeah. I hadn't thought about it. This is a minimal crew compared to that plan. I personally would not have the inflatable sticking up in the air. I'd put them sideways and low, so I just feel more secure in them. They're easier to shield. But there's a whole range of plans. You could morph one plan into the other. Let's say use the microphone or shout. So.
I was just going to suggest that you're going to send 2 people out,
yeah,
or four people out, 2 stay in orbit. The 2 that are in orbit for 2 years are not going to want to take that mission unless they get to be the next 2 to go down and replace them with 2 more from Earth that spend that next cycle in orbit.
Yep.
And I think you keep cycling people into the...
Yeah. I'm hoping that it's expensive to maintain the people in orbit. And they might be taking a radiation dose. They might be in zero gravity. I would prefer to have a shielded spinning space station, but that's expensive. So as soon as the base on the surface is reliable, I would eliminate the people in orbit and bring them back home. But yeah, they could go down to the surface. Right, yeah. A lot of people have said that you want to bring some people back so they can take the ticket tape parades and give speeches and shake hands with everybody who funded it. and get more funding. So it's a trade-off. Yeah. I think there'll be no shortage of volunteers. Lunar command module pilots. The lunar command module pilots never set foot on the moon, but they still went. Yeah.
Why exactly do you need the people in orbit?
To decrease the risk to the point where it's acceptable for us to fund it. You really don't need them, but it would be risky to go there without them. And if it was a national emergency, if we saw some comet that's going to hit the Earth and wipe us out, we just go straight to Mars, no question about it. Yeah, but by having the people in orbit controlling the rovers, you can do site selection much faster, and you can have a bunch of rovers running around, assuming they have power to move quickly. Now, most of the decisions and the controlling would be done back on Earth, but the people in orbit could make quick decisions and then turn it over to the automated guidance, and then go on to another rover, make a quick decision, go on to another rover, make a quick decision. And then once you deploy the human-rated habitat and chemical processing and whatnot, it'd be nice to have that fast decision making and being able to test them in real time. So that's the reason. You also can do a fair bit of exploring of Phobos and Deimos. One comment I didn't have time for is there's a crater on Phobos called Stickney, and it faces the planet. You guys remember the Death Star with that big crater on one side and the rays come out? Well, Stickney is aimed right at Mars. And if you sit in the bottom of Stickney and look overhead, if you lie on your back and look overhead, the planet Mars stretches from directly overhead to more than 40 degrees from overhead. It's like almost halfway to the horizon. You actually get significant shielding from Mars on Phobos, if you can believe that. So, yes?
How big a greenhouse and how much different types of food you have to grow to support each person on the ground?
Yeah. How big a greenhouse? I have not done any of that work. I have read wildly varying numbers. Somebody just told me you can support somebody on the size of this little platform here. I don't believe that. High intensity light, elevate the CO2 by about 50%, increases the yield of tomatoes. You can have multiple layers of crops, as I showed in one of them. You can do it pretty intensive, but okay. Okay, for this plan, for the Hillside Settlement, our agricultural specialist said about half of the square footage of the base would be greenhouse, but it's single-layer greenhouse, mostly. Well, single and double layer, but it's not like 10 layers. And another quarter of that is manufacturing facility, and so it's. By the way, for this one, we were also growing non-food crops. You'd be growing linen and bamboo and cotton and maybe extra soybeans to make soy oil to feed industrial processes. So we actually devoted a fair bit of acreage to non-food. More questions? Okay. Please leave me your email address and contact information if you are inclined to help with any aspect of this. So, okay, I'm going to hesitate for 30 seconds to let people politely leave, and then talk about the thing with WPI students. And that I'll come down and be not on my pedestal and chat. So, yeah. Yeah, for a space elevator on Mars. It is apparently feasible to make a space elevator on Mars with existing materials. Polypropylene, which is used in fishing line, can actually be good enough for a Martian space elevator. You taper it a little bit. Phobos and Deimos, everybody thinks Phobos and Deimos will cut it. It's an easy solution. You just anchor it away from the equator, and they zip right past it. I personally like rotating tethers in orbit. You put a big heavy station in orbit and a tether attached to it about 8 kilometers and have it spinning, and you can pick up spacecraft that are coming up at suborbital velocity. It lessens the need for a second stage on the Ascent Vehicle. I don't remember the figures on Mars, but I can tell you the figures on Earth. Orbital velocity is, let's say, 7 kilometers per second for a low to medium orbit on Earth. And I did some work with a rotating tether where it was 8 kilometers long, rotated at, I think it was 4 RPM. And another version that was 40 kilometers long at 1.25 RPM. And if the tip speed is 1.5 kilometers per second, the tether has to be 8 times more massive than the payload. Okay, so if you have a 1-ton payload, you need an 8-ton tether. But that's okay because it's reusable. Okay, and instead of going up at, so you leave Earth, go up, instead of going to 7 kilometers per second to rendezvous, you go 1.5 kilometers slower than that. So that'd be 5.5 kilometers per second. So instead of being a 2-stage rocket, it's a 1.5-stage rocket. You grab the end of the tether, and it pulls you in. Or you swing halfway around. Okay, so the station's moving in orbit, and the tether's going around it like this. Okay, actually the station's rotating. And you come up and you grab the end of the tether, and then you swing halfway around. This will be interesting on camera. And you go flying off. You've gained 1.5 kilometers per second when you grab it. You gain an additional 1.5 kilometers per second when you let go. You're now going 8.5 kilometers per second. This is a really good way to throw communication satellites up to a medium orbit. You get 2 of those tethers, and you can throw things to the moon, to near the moon. You get a 3rd tether in lunar orbit, and you can catch the payloads, drop them down, mine some dirt, lift the dirt up a safe altitude, catch a tether, go back to one of the stations, refine the dirt into aluminum, steel, and fiberglass, manufacture more earth-moving equipment, send it to the moon. And that's a half-hour presentation. So I've got it on a website. But yeah, Mars would be even more amenable to that because the orbital velocity is lower, the gravity is lower. You would need much less of a rocket to catch that tether than to get to orbit on Mars. A space elevator would work, but it'd be hard to justify it early in the program. And what I'm worried about is how to get that initial program going. And once you get people on Mars and manufacturing on an asteroid, then everything takes off, and the details are much easier.